Space travel, it's a dream as old as humanity itself. We've gazed at the stars for millennia, wondering what secrets they hold, but to reach for those stars, we need a powerful force. That force comes from rocket fuel, also known as propellant. Propellant isn't just one thing, it's a mixture of two key ingredients, fuel and an oxidizer. Think of it like this, you need wood to build a fire, right? But wood alone won't burn. You need air, or more specifically the oxygen in the air, to keep those flames going. In a rocket, the fuel is like the wood, and the oxidizer acts like the oxygen in the air. When combined and ignited, they create a powerful explosion that propels the rocket upward. But unlike a bonfire, rockets carry their own oxygen supply, allowing them to burn fuel even in the vacuum of space. It's a bit like bringing your own personal oxygen tank to a campfire on the moon. This powerful combination of fuel and oxidizer is the key to breaking free from Earth's gravity and venturing into the cosmos. But there are different types of propellant, each with its own strengths and weaknesses. Let's explore them. First up, we have liquid propellants. These are like the thoroughbreds of the rocket world. Powerful, efficient, but needing a bit more care and handling. Liquid propellants are stored as separate liquids, the fuel and the oxidizer, and pumped into the combustion chamber where they mix and ignite. One of the most common and efficient liquid propellant combinations is liquid hydrogen and liquid oxygen. This dynamic duo powered the mighty Saturn V rocket that took us to the moon. Liquid hydrogen and liquid oxygen burn incredibly cleanly, leaving behind only water vapor. Talk about eco-friendly space travel. Another popular choice is RP1, a highly refined kerosene combined with liquid oxygen. While not as efficient as liquid hydrogen and liquid oxygen, RP1 and liquid oxygen are denser, meaning you can pack more energy into the same volume. This makes them a good choice for rockets carrying heavier payloads. The beauty of liquid propellants lies in their controllability. You can throttle them up or down, even shut them off and restart them mid-flight. This fine-tuning makes them ideal for maneuvers in space and precise landings. However, liquid engines are complex and require intricate plumbing, making them more expensive and challenging to develop. Next, we have solid propellants. Imagine a giant firecracker and you're on the right track. Solid propellants combine fuel and oxidizer in a stable, solid mixture that looks and feels like hard rubber. A classic example is ammonium perchlorate combined with aluminum powder. This potent mixture is packed into the rocket motor casing, ready to ignite. When ignited, the entire mixture burns, producing a powerful, sustained thrust. Solid rocket motors are incredibly reliable and simple. They're like the trusty pickup trucks of the rocket world, rugged, straightforward, and ready to go at a moment's notice. Their simplicity also makes them relatively inexpensive to manufacture. However, their simplicity comes with a trade-off. Once ignited, solid rocket motors burn until all the fuel is gone. You can't throttle them or turn them off. Think of lighting a firework. Once it's going, there's no stopping it. Finally, we have hybrid propellants, a sort of best of both worlds approach. These systems typically use a solid fuel and a separate liquid oxidizer. Virgin Galactic's Spaceship Two, designed for suborbital space tourism, utilizes a hybrid engine that burns a rubber-like solid fuel with nitrous oxide, also known as laughing gas, as the oxidizer. Hybrid systems offer greater control than solid motors. You can throttle the engine by adjusting the flow of the liquid oxidizer. They're also considered safer than solid motors because the fuel and oxidizer are stored separately, reducing the risk of accidental ignition. However, hybrid propulsion is still a relatively new technology, and hasn't reached the maturity and efficiency levels of liquid or solid propellant systems.